Hello, in today's session we are going to solve an example of one-tailed hypothesis testing, and with me I have a sample case that you're going to use whereby we have a sample of 100 cars as a mean of 20,000 miles and a standard deviation of 800 miles. Using 90% level of confidence, can we conclude that the population mean is less than 21,000 miles? So the first thing that we need to do when we get such a question, it is to state the hypothesis. We need to state the hypothesis. So in this, we are supposed to say that if the population mean is less than 21. So in this case, I have my null hypothesis being, so if I have the null hypothesis here, I have the null hypothesis here with this is our hypothesis mean, which is, we are told is less than what, 21, less than 21,000 miles, less than 21,000 miles. And then also we need to state our alternative hypothesis, and in this case our alternative hypothesis, which is the sample mean, we are told that it has a mean of 20,000. So you can see it is less than this 21, so which is also going to be less than 21,000 miles. So, and we are given that the level of confidence that you're going to test is 90%. So in this case, we can have a sketch of our normal distribution here. Can have a sketch of our normal distribution, and in this case, for us to be able to know which of the side we are going to have the acceptance region and the rejected region, so we can shade. We have the 90%. We have the 90%. So whatever will be on our rejected part will be 10%, which will be equivalent to 0.1, and then remember the remaining is equivalent to 0.9. So for us to get the critical region, or the critical regions that is bound by the shaded region and the accepted region, which is equivalent to this. Remember, this side we are not shading because it is specific on the left because of the less sign. So to get this critical, you can get the area under the left curve, which is always given by 1 added to our confidence level, which is 0.9 divided by 2, and then the value that we get, we look it from the z table. And for our case here, our critical region boundary is supposed to be 1, maybe for example it's supposed to be, in this case we have it being 1.6, which is on the side positive side is 1.645, so on the negative side it will be negative 1.645. So now with that in our mind, we need to get to calculate or to test our hypothesis using the z square. So, and in this case we know that our z is going to be given by our sample mean, then we subtract the mean of the hypothesis, and then we divide by the standard deviation divided by the square root of the sample space. So the reason why we are using the z is because our sample that we used was greater than 30. So for us now, we can come and place these values in our formula, because from our question we know that our sample mean is equals to 20 20,000 miles. And then also our hypothesis mean is equals to 21,000 miles, is equals to 21,000. Then standard deviation, we are given it at 800 miles. And then the sample space, which is our n, we are given as 100. So our z-score now is equals to 20,000, then subtracted 21,000. Then this one we divide by our standard deviation of 800 all over the square root of 100. And if you subtract 20,000 and 21,000, you get negative 1,000 divided by the square root of 100 is 10. Then that we get the answer equivalent to 80. So we get now our z is equivalent, if you divide it 108, because this 0 and this can cancel, we get negative 12.5. And if you come to plot negative 12.5 to our curve here, it goes on the far left side on the shaded region. So here on this side, it is where we have the negative 12.5. And so we can conclude that we reject the null hypothesis and maybe conclude that the population is not less than 2100 miles. Hope you have understood and you have benefited. And if you have benefited, consider subscribing, like and share to reach more students and people so that they can have the same knowledge. I was your trainer, Maurice Monene. Thank you.